Hello, good afternoon. Today we're going to talk about the normal curve and the z-scores and how we could use the normal curve to find probabilities. First of all, why this is important? This is important because we need to understand what the typical behavior of a process, and then once we study the process, we could find out if the process behaved within the normal limits or it requires some more investigations and look into areas for variations and maybe process improvement and these kind of things. So a normal curve will help us to study the data that we have to make sure the data fits to the normal situation. In this presentation, I will be talking about the probabilities of normal curve, mean and standard deviation of the normal curve, area under the curve, calculating the z-score. These are mainly the topics that I will be covering in this presentation. So here's a normal curve. As you see, we've talked about the histogram. We've studied about the histogram. The normal curve, it's a hypothetical curve that fits all the data under it. So it is kind of a histogram. As you see in this histogram, you will see different columns, and we try to fit the normal curve within the most common data. And through this, we could calculate the standard deviation, we could calculate the mean, and we could also find out if this is a normal data or not. It seems to me in this example it is a normal data, except we have some outliers that we should investigate on the hours between 40 and 50. That long bar, as you see here, that would be an area where you need to investigate what exactly is happening. For this one, the theoretical normal curve is divided into areas, starting with the middle point right there at the 0. As you see, the z value is 0. And there are 3 standard deviations on the right side and 3 standard deviations on the left. Each standard deviation would be equal to 34% on both sides. So one standard deviation, that means 34% of the data located into that area. -1 standard deviation, also same thing, that would be equivalent to 34% located in this area right here. Also, what I would like to mention now, if we combine the area from 1 +1 standard deviation and -1 standard deviation, that would be equivalent to 68.26%. If we're talking about 2 standard deviation, that would be 47% of the data will be located on the right side of the 2 standard deviation. Same thing on the left side, whereas the -2 standard deviation, we have a 47% located of the data located in that area. A 3 standard deviation would be the 99%, or just to make it simple and clarify, we say 50% of the data is located on the right side of the 3 standard deviation, and other 50% is created on the left side. So let's do again one more time. Let's review this. If we could remove this here. Okay, we have, as I mentioned, we divided the theoretical normal distribution. You will see 3 areas, 3 on the right side in the positive, 3 in the negative sign. Each area will be specified, and we know that under plus one standard deviation, that would be 34% of the data located under that curve. If we say what is the data located between -1 and +1 standard deviation, that would be 68%. If we're talking about the two standard deviation between plus and minus two standard deviation, we find that 95% of the data located between plus and minus two standard deviation, and about 99% located, or 100% as I did include it here, which is located under the three standard deviations. So some properties about the normal curve. A theoretical construction. This is the first one. So it is based on theory. It's called the bell curve because it looks like a bell. If you have a normal distribution, you will see a symmetrical shape, which means the right side is equal to the left side. The mean of a distribution is the midpoint. So look into the midpoint of that normal curve, and you will find that the mean. The tails of the curve are infinite. This is some properties, and this is based on theory. In real application, we consider whether like a standard deviation to be a 3 standard deviation, or most companies, they aim to go to the 6 standard deviation, which means only through 3 mistakes in 1 million production units. So this is the optimal goal. If we have a normal curve, the mean of the curve is equal to the median, and that would be also equal to the mode. The area under the curve is measured in standard deviation for the mean. So how we are far from the mean. So the goal is the mean. So this is the center. This is where supposed to be. This is the target. It should be in the center. And now we describe the data based on how far this data away from the target, which is the mean. So in a mean, in a normal distribution, you will see the mean to be equal to 0, and the standard deviation would be equal to 1. So as I mentioned earlier, the 1 plus minus 1 standard deviation, that would be 68.26% of the data located in that area. Plus minus 2 standard deviation, about 95.44% is of the data located under that plus and minus 2 standard deviation. And for the 3 standard deviation would be 99.72% is located under that area. These are just some facts that you need to know about the normal curve, and this will help you. So this will help you to calculate the area under the curve. So now, some people, they would think, as I mentioned, most companies, they're looking to implement 6 sigma, which means reducing the number of errors to be 3 defects per 1 million production. And what does that mean? That means that most of the data will be located closely to the mean, around the mean. So if you look into this chart, you will see the 6 sigma curve is it's most of the data clustered around the mean here, and it's mainly most of these points are located around the mean, and this is versus the 3 standard deviation, more wide. You will see a more spread. So the more variation in quality, the less quality. We need to ensure that there's no variation, minimal variation in the process to ensure the high quality. So this is just an overview of the normal curve and some of the facts about the normal curve that will help you to understand what is the normal curve. Why is it important? Why is it important? Because we need to identify how many of the data located in under 1 standard deviation, or 2 standard deviation, or 3 standard deviation, and this will give us a better measurement for the variation. We don't need a variation. We need to remove the variation as much as we can, and this will improve the quality of my product or my service. So this is something that we could consider by studying the normal curve. Moving on to the z-scores. These are basically a way to determine the position of a single score under the normal curve. So we need to identify, saying, okay, if we have a student, let's say in your example, you took the quiz 1 and you said, okay, I achieved 60% in this quiz. So your question is how I am located or where I am located between the rest of the class. So this z-score will help you to understand where are you located comparing to the rest of the class. The same thing for manufacturing or process or process in a service industry. You could say, okay, I served this customer within 4 minutes and 20 seconds. So is this normal? If it's normal, where is located under the normal curve? So it is the z-score will help us to determine the position of the single score under the normal curve, measured in standard deviation related to the mean of the curve. So what we do, we use the mean. As we know, the mean will be in the center of the normal curve. We need to use this as whether on the right side of the mean or the left side of the mean or where exactly this point is located. The z-score can be used to determine an area under the curve known as probabilities. Probabilities for this data. So we need to know exactly. So what is the formula? The formula would be the x, the point that we're talking about, minus the average of all points divided by the standard deviation. We'll take more examples in order to be able to understand how we can calculate the z-score and the area under the curve. So theoretically, in the theory, we say the area under the normal curve is 100%. It's not exactly accurate, but we know that there's an infinite limits for the normal curve. But however, to simplify things and make it more manageable, we say the total area under the curve is 100%. 100%. The mean is in the center of the normal curve. Let's take an example here. Study the normal curve. Example 1. Which normal curve has the greater mean, A or B? We know that the normal curve or the mean would be in the middle of each, let's see if we could find the pen here. Okay, so the mean for A would be about 15. The mean for B is about 12. So how did we know that? Because we know the mean will be in the center of the normal curve. Therefore, A will have a greater mean than B. Moving on to the next example, which curve has the greater standard deviation? And the standard deviation is the spread of the data, how far the data are spread from each other, or how the data are spread from the mean. So we know that the mean is here, and the mean for B is in the middle of the curve for B. And we see that B, the curve B is more spread than the curve A. And this will give us an idea that the curve B has the greater standard deviation because, as we see, it's more flatter, the data are more spread out than the curve A curve. Now, how we could use the normal curve and the z-score. Here's some quick steps that I've listed here to help you understand how you could calculate the z-score, the area under the curve. So the procedure is like this. To find the area, first compute the z-score. So now what we need to do, we need to find the z-score, the first thing. Substitute score of interest for xi. Use sample mean for the average x or x bar, and sample standard deviation for s. The formula changes a raw score from x to the standardized score. So first of all, we need to find the z-score based on the point that we're using, based on the standard deviation, based on the average for the data. And then once we have the z-score, what we do, we go to Appendix A, and where you could find the areas above and below the score. We need to find exactly what is the area, whether above or below. Once we compute the z, we need to take careful note of the sign of the score. Is it negative or positive? Because there is a table for the positive scores and there's another table for the negative scores. We need to exactly know where which table to use. The last point here we can find in order to be more accurate, and this is my preferred method for calculating the z-score, make a rough sketch for the normal curve and shade in the area in which you are interested in. Here's an example. Let's take an example here and find out what would be the area under the standard normal curve to the right of 0.87. All right, so the first thing you need to do, I would prefer you create a normal curve, and the normal curve would be, it could be a rough, not you don't have to have an accurate. Okay, so as you see here, I'm going to create here in front of you, see how we could do that. So we know that we on the left of z.82. So now we know that the standard deviation is 0. We know that 0.87 would be somewhere around here on the right side, the majority of the area under the curve, because we know that the area under the curve is 100%. So we know that 87% somewhere on the right side. So what we need to do, we need to find the area under the standard normal curve to the right of 87. So this is 87. We need to find the area on right here. Okay, so first of all, what we need to do, this is a z-score. It is given to us, and the z-score is to be 87, or the point is 87. The z-score is to be 0.8078. And how we could find this? Let's take a closer look into the table. We know that the z-score to be z equal to 0.87. The probability based on the table, go to the positive, go to the 8 and 0.7, and that would give you the probability for having an 87% score. However, we're looking into the right side of it, so we're not going to, no, let's go back here. So we know that this area here to be what? 0.807. 0.8078. Now we're not looking into this area. We're looking into this area. So we know the whole thing is 100%. So 1 minus 0.8078, that would be what the area that we're looking for. And that would be equal to 0.1922, which means 19%. 0.22 of the data could locate it on the right side of that. All right, let's see if I could repeat that one more time. I know this is a really important topic, so I want to make sure that you understand what we could do here. Okay, so again, the score is to be 0.87, and this is the z-score. It's given to us. We don't have to calculate it. We don't have to use the equation. The equation is to be, the equation is that we usually use is z equal to the x minus the average divided by the sigma. So in this case, we don't have to use that equation because the z is already given to us. So what we need to do, we just sketch the area under the curve, and we know that we are looking into this area right here on the right side of 0.87. And what we need to do, we need to use the appendix, the probability table. You go into 0.8, 0.07, and you will find that the area on the left side to be 0.8078. but this is not the one we're looking for. We're looking into the right side, so that would be 1 minus 0.8078, and therefore 19%, 0.22 would be located on the right side of 0.87. Another example, find the area under the curve, the standard normal curve, between 2 and 3. Between 2 and 3. In order to calculate this, we know that this is the z table. We don't have to use the equation. We're looking into the area between these and these. Using the probability table, you could find what would be the area from 2 all the way to the left and from 3 all the way to the left. You subtract both of them to find out what would be exactly the area here. So using the normal curve, the probability table, you find that the probability for 2 would be 0.9772, and the probability for 3 would be 99.87. So you subtract these both areas from each other to find this small area to be 0.02. Let's have one more example, and then we'll move on with the next topic. The weight of 10-year-old girls are known to be normal. So this is something that we're happy. So it's a normally distributed. So it is a normal distribution with a mean of 70. Okay, we know that the mean is 70 pounds and a standard deviation of 13 pounds. Obtain the percentage of 10-year-old with weight between 60 and 90 pounds. So we need to find out the percentage of the girls between 60 pounds and 90 pounds. The first of all, what you need to do, sketch the normal curve as you see here. So I have the mean to be 70. That's in the middle, the 70. We're looking for the mean of the percentage of the girls between 60 and 90. 60 is on the left of the 70. 90 is on the right of the 70. Now we highlight the area that we're looking for. So we sketch that. We know that this is what we're looking for. And now let's find out how we could find the z-scores. The z-scores. So number one, or the following step, after we sketch that, we sketch the normal curve, we highlighted the areas. The next step would be compute the z-score for the 60 and for the 90. So using the z equation of x minus the mean divided by the sigma, that will give us, for the z value for the x 60 would be minus 77, and the z for x equal to 90 would be 154. 154. Now what we have to do, we have to go find the probability of the z within the delimiting z-scores. The probability corresponds to the area under the standard normal curve between the two values. All right, now we have to find out what would be the probability for 154 and minus 0.77. Okay, if we know what would be the area under here, and we know what would be the area under here, we could subtract these from each other to find what the area between them. Okay, go into the table, see if I could find the table here, just to show you. And just a second point. All right, now here, right here, what we need to do, we need to go to the z table and find what would be the minus 0.77. Okay, let's go here, negative 77. So here's the row, this one right here, 77, and we need to go to this one. So this is the 0.7, and this is, so that would be 0.2206, 0.2006, 0.206, This is the one. The other one, 1.54. Let's go to the positive table. 1.54, 1.5, and then we go to the column of 4, which is 9382, 0.9382, 0.9382. Subtract these both from each other. We found that 0.7176 is the result. Therefore, we conclude that 71.76 of the girls weighed between 60 and 90 pounds. I did put some questions here for you to help you with this topic. However, I also included this link. It's very helpful. It will give you an idea, an easy way to find the area, whether under the curve or above the curve or between the curve. This is helpful and handy when you have a quiz with a limited time, so you could use this. However, I do prefer to use this math and these calculations to help you better understand the topic. But eventually, once you are on the run, you have a quiz with a limited time, you probably want to use this link. I'm going to stop right here, and I hope this is helpful. Please let me know if you have any question. Thank you.